so linear independence.
Okay.
You want to make sure that all your sequence of SPRs, you don't change your weight matrix or anything to something that's linearly dependent, because that's bad. And they call it, the SPRs an admissible structure if it's a G-invariant neural network that, is non-degenerate. It just, works as it should. And he goes through saying how to, make that sort of thing, like recursively. How do you build it, essentially? Theorem 7 is saying, hey, I have some sequence of sign permutation representations. I want to make sure they actually give me a good deep neural network that's G invariant. And it gives you a sufficient and other condition, if and only if, saying that this is a good architecture if some conditions hold.
Okay.
Yeah. Otherwise, you have something that disconnects a node or glues two nodes together, which we probably don't want to happen
Yeah.
for a neural network.
Have you looked at the examples, to know if they're like good to try to follow along if you get lost in notations?
I haven't read through the examples too much. I just know there's a typo in the first one. But the examples are very much based off of the notation that's used.
Gotcha. So if you're misunderstanding stuff in the text, the example may not be the most helpful either way.
Yeah. I need to go through that.
The model is heavy, that is why it's taking so much time. Each time you're doing something.
And then, the conclusion just says, hey, here's stuff that we want to do later.
Jack really gave you this layout, right?
Yeah,
but I gotta change some
then
stuff.
you have the proofs of all the theorems.
The
Which
phone
may be something
pass
to,
out after hearing all of this.
skim through to at least get a good idea of what's going on.
Have you read
Yeah, that's approved, that's approved.
Paper?
the question for it for this assignment?
One time.
So,
I mean, probably at this moment we're not able to
Appendix B,
answer those questions.
Appendix
We don't have
B may
that
be
yet.
good to
I'm
look
gonna
at.
Okay.
Because
I'm gonna
it
take
says
this
like,
out.
hey, here's why skip connections or being
I'm not
used.
pretty sure
How
we have
to,
to go that. I mean,
why,
deep
like how
in the
we can,
paper.
write skip connections as a
Pretty sure we
reparameterization.
should go that, but do we actually
It looks
have to
like.
go this
And
in
then they use that to prove proposition
He
3.
said write one
Okay.
page about what
Which-
you understand.
Yeah.
A lot of math, but if you look at it, closely enough, it's just matrix multiplication.
Yeah, that's what it was.
Yeah. Again, the proof of lemma 4 is matrix multiplication for the most part. Well, not.
That's basically the
same, but
model.
Lemma 5's proof is multiplication.
L from
Lemma,
I'm pretty sure.
theorem 6 is just using equivariancy. And then invariancy, yep, still equivariancy. A theta function
should
for
be
the
working
admissible architectures. They
The
give
doctors
another proposition
Assigned there.
that establishes the invariance and equivariance of this theta function that is used for proving something is admissible, and like some properties that it has.
Let's go
And
from
then, they actually
That's the
give an
criteria.
algorithm
criteria one.
that implements everything.
That algorithm one.
Yeah. Like here's how you build this theta function that checks if something is
The doctor.
admissible.
Check this out.
And it's written in GAP, which is like a purely group theoretic programming language.
Mm.
It's kind of cool. So cool. Proposition 9 says the algorithm correctly implements that theta function, which is funny. Then there's a phi function
Still right.
for a lot of extra math, and that's too much math. Patch norm thingy of the value.
In here, supposedly,
Examples,
we are like going through
a
the flow.
proof of example
At this
1.
point, a doctor should start. Should appear.
Wait, is that still in
and start
the
going
B index?
that way.
No,
Appendix.
it switched to appendix C.
One
Okay.
psychologist.
The first couple parts of B
There's something
good.
wrong here. I
then
don't
become
know.
like too mathy to follow.
Let's go. Let's go again.
C
Do you want to change the C
looks like
function?
it's actually doing the
Let's
binary
go.
multiplication.
Those are the psychologists.
I think. Using the value,
Are they
Probably.
actually moving? Yeah, they are moving.
that's weird.
Let's go to the memorial.
I'm assuming this actually, becomes binary multiplication.
They never move.
And then no references.
Change
And
the
they
function
kind of
of the
just,
C.
skip over example
To
2
what?
altogether.
Or go to move to.
We have
Does move to have C stock in it? Go to move to.
So yeah, you basically just
Mm.
need
Everything
a
starts from here.
intuitive idea of what's
Psychologist.
going on.
No.
Mm.
Okay, we need to make sure everything respects the group symmetry that we apply to our data.
There is no connection between move to and C stock.
And then how you do that
Yeah,
is
there
lay
is
down everything
connection.
else.
It's connected because the nodes are
How you,
black. That means
like if
those
you're
are
given sign representations, this is how you make it G invariant, like in practice. That's the lemma 4. Proposition 3 says that, everything's, invariant underneath certain transforms. Lemma 5 makes everything. There's another way of constructing these signs,
size up.
not by recursion, but through iteration. So you can
This
just do
point,
a for loop instead of a, recursive.
The doctor is not possessed by anyone.
But apparently in practice.
The
doing
doctor
recursions,
actually
the
is
way to
gonna
go.
like grab someone, is gonna grab the patient, and
And
is
then
gonna
there's
possess
something
the
in
patient.
Theorem 6
And the doctor is not possessed like someone.
about like, hey, this
He's
new
the one
way
who's
of
gonna
doing things
process the patient.
actually keeps things invariant. And then
That the
theorem
normal
7,
one?
or
No.
proposition, theorem 7
Child.
is way to say, hey,
Size.
I have my SPRs here,
Let's do that
I'm
one.
going to check if they are admissible. If they give me a good
Patience.
G invariant structure. And if
Oh,
they
wow.
don't, then.
And psychologist,
well,
because
then-
the
Yeah, you gotta
The
use
psychologist
something
will
else
move.
because
Yeah.
that has
so
to
the
be.
resource is psychologist.
that can't be violated.
Yeah. Like this just says, hey,
Let's see.
if I have these, I know they work or don't work. Finding the best ones is still an open question.
Future work.
Yeah, exactly, future work.
Now it's working.
But,
No,
yeah.
let's see the model. The same was
I feel like that's not.
model area.
Class tomorrow.
Still,
upon review of
we
those.
should have something here. Yeah,
Upon
well,
review
here
of
we
notes
are
and then
assigning.
we need to make some
Yeah,
progress.
it's true that we are assigning the doctor in here, but the
I'll be doing
doctor
a combination of that.
should come from somewhere,
Yeah.
then move.
In best case scenario, he
I think
reaches us and be like, yeah, I actually didn't understand a lot going on with this
Yeah.
paper either, so
Well,
we're just not gonna have this assignment.
I think that the previous option was
I get
selected.
it.
That means
And
that
he ruins
the
it for all of
doctor is
us.
gonna go towards
But,
the agent that possesses the
It'd be
dog.
okay.
yeah. Just, try to write notes or
We
something.
can take that as a
Yeah, I feel like I've got enough relevant
Can you go
things to
to-
write notes on. Because like,
I just wanna see what's
part of me is like, yeah, I can go through and
goes
take
to
notes
the storage.
on the paper, but I'm
Graphs.
having to
It-
learn a
it
lot of
should go.
stuff to actually
Can you
understand the
see
paper.
where
So
this
I think those
actually
are also
happens?
things to take valid notes on. If you take that into account, I've got like 10 pages of notes.
No,
in
can
my
you go
Congress
to the
book.
treatment?
So just throw some of those on there and I've
I
at
just
least got
wanna
half the
know-
requirements of the assignment done.
Yeah.
So I should have enough for that already, and then it'll just be a matter of understanding the
Oh,
paper
can
notes and writing
you
the
go?
referee
Say
report,
no.
which I'd probably be
Usually go
fine
back.
going a lot
NP.
Wait.
easier on that than what I did for the other referee reports, because for those other ones, I could actually
It
understand
goes to
parts
the
of the paper
storage.
Yeah.
S
without
is the
too much
storage.
thinking. So
Like
I'll probably go,
this is MP. The noise
I'll probably
goes to
use
the
a fair amount
storage.
of notes.
Grabs
and
the
then
file.
a
Move.
shorter referee report.
Can you go to
and
this move? I'm
probably
pretty sure
take my 7 out of
that's
10
the
down.
same like structure. It goes
Well,
W
I really
to
don't
T
know how
is
he's
pretty much.
going to class tomorrow.
Yeah.
Yeah.
Because I don't think.
It goes to
anybody
that.
Now
is
run
going to be able to write
It
the
goes
report
there.
properly
Yeah.
for this.
So the doctors
I would definitely
should
agree
go
with
to any of these rooms.
Like they can do all
Should
the
the doctor
notes
should
easily,
be
but
going to any of those rooms? So we have to put it
at
like
face value, it
dynamic ways.
looks
We
good.
cannot just say it goes to a specific point
But then again, you need
where any of the
good knowledge.
it
of
could
the
be
entire
either
subject
B1,
to
B2,
know
B3, B4,
why it's not good.
up to B6.
Yeah.
Which you won't have in this department, I don't think.
Yeah.
In most math departments either.
Or can you go just back to the first
But
subject?
oh well.
Is the one
Do
that
the comp sci.
is more
maybe.
logic?
I don't know.
Oh, computer science knows the neural network part of everything. The math
Can you
people,
run this one once?
most of them can get the, algebra.
I just wanna see that if the
and
doctors go to the B1 or
representation
not.
things. Not many people can get the intersection. This is very interdisciplinary.
Go to the model.
And then you have me that's trying to toss, quantum out all this.
The same
the
is
super
happening.
intersection.
Yeah.
I feel that we can just simply
And I think
take
we're
care.
done for today.
But this is explaining that the doctor
I'll help you with the.
moves from wherever he is
I should work on that or.
and he meets the patient too.
Tomorrow.
See that.
Bingo.
See what?
What?
Bingo.
Oh, y'all coming?
Yeah,
Oh, I was not aware of that.
it was his name
Like,
though.
It
The
was his name.
the
Well, then I will see y'all in a couple hours.
Yeah.
settings of these should be the same as these.
Well, not all, I don't know.
I don't think should be the same as those.
Okay, yeah.
Move 3. Okay,
Yeah.
check that.
Next to you.
Can we go upstairs a
Maybe I
little?
should
Yeah, we can.
try to read the there's no